Alright, I snuck 0 in on the last page when we were multiplying. I'm going to be more direct here, talking about 0 for a moment before we try some division with positive and negative numbers. They take a quick pause, just like they did for the multiplicative inverse up above. Oh, by the way, we are on the bottom of page 2 in 1.7. So 1.7, page 2b. And they take a moment to talk about 0 involved with division. And the instructions say to perform the indicated division or state undefined. So let's look at what two possible situations we could have. The first one is 0 divided by a number. The second situation is a number divided by 0. In the first situation, 0 divided by -8, that answer is going to be 0, and it's always that. It's always when you take 0 divided by any number, it's always equal to 0. The second example has those two spots reversed, the inverse of it. It's -8 divided by 0, and I really should clarify here what this means is 0 divided by -8. And what this one means is this is -8 divided by 0. And that one, we have to say that it is undefined. There is no way to give an answer to that. And that is true for any number divided by 0 is going to be undefined. There is no answer we can give that, okay? Always. That's always our answer for it. Now, why is that? Well, if I were to look at what happens with numbers, and this is not a proof, but this is the beginning to understand what's really happening. 0 is a number, so 0 has to follow all the rules that the other numbers do, okay? It's no special priority. It doesn't get to break any rules just because it happens to be sitting right in the middle of the number line, okay? So here's an example. If I take 6 divided by 2, my answer that I get is 3. If I take 6 and cut it in half, I should get 3. Or 6 marbles divided by 2 kids, each person gets 3 marbles. Okay. Well, multiplication is the opposite of division. Multiplication undoes the division. So you'd multiply to undo or to get back to the original number. The original number was 6. Here's the original. Then we divided by 2 and we got an answer of 3. So if we want to see if we can get back to the original, you take your answer, and here's your divisor here. You would take your answer times your divisor. This is blue here. And that would equal your original number. In this case, 3 times 2 would equal 6. 3 times 2 would give you back to 6. 6 divided by 2 is 3. 3 times that divisor equals our original number, 60. Okay? So let's look at that in terms of 0 divided by any number. Okay? If we have 0 divided by any number, let's go with 0 divided by any number, means that we've got 0 divided by that number, and we're saying the answer is 0. Okay, so here is our original number, 0. Here's our divisor of, could be any number here. And then here is our answer. And because this is division, the opposite operation, multiplication, should undo it and get back to our original answer. Okay? So we would multiply to undo the division. We would take our answer times our divisor, or the quotient, you could say. The quotient times the divisor should be equal back to our original. 6 divided by 2 is 3. 3 times 2 gets us 6, which brings us back around to where we started from. So let's see if that's the case. We've got 0 divided by any number. We're saying that always equals 0. Well, let's check it. The multiplication should get us back to our original here. So we take our answer, which is 0, times any number. The divisor was any number, it's a variable essentially, and that should equal our original. Does it equal our original of 0? Is this a true statement? Yes, because 0 times any number brings us back to 0. So we're okay. That's where that rule comes from. It's a way to define this answer based on what we know about the relationship between division and multiplication. So let's do that same thing now, but with our negative 8 divided by 0. Okay? And I should have highlighted here that what we wanted to recall was what's happening over here on the side, that this multiplication and division relationship exists. But what if we have any old number divided by 0, which really means we're taking any old number divided by 0 and we're coming up with our answer. Okay? The question is, what is that? Okay, it's tempting to say it's 0, but we have to look back to see what we need to get here. So, if this were to be true, it means that we would take our original, and here's our divisor of 0, and we'd come up with our answer. And again, we would multiply to undo this. Because multiplication and division are opposite operations here. So we've got our answer times our divisor is equal to our original number. So our answer times the divisor, so we got to go backwards. If we can do this over here, answer times our divisor is equal to our original number. Over here, our answer times our times 0 should be our original number. Well, right there, we've set ourselves up here. We say, okay, does this have an answer? What is that answer when you divide by 0? Well, if we go ahead and multiply that by our divisor, and our divisor is 0 at this point, because that's what we were dividing by originally, then our final answer is going to be 0. Every time. Every time we multiply by 0, our answer is going to be 0. Well, was our original number 0? No, not necessarily, because we said any number could be here. Any number divided by 0. So it's not the case here. The original was not guaranteed to be 0. So there is nothing we can put as an answer here that we can then turn around and multiply the divisor and get back to our original number, because that divisor is 0. So we cannot define an answer for a number divided by 0, because we can't take that answer and work our way back to the original, because working our way back means we're dividing by 0. So that's why we say this is an undefined process. This is a process where we can't put a number or an answer on it and still have it follow all the mathematical patterns that we know to be true. Okay, so a little bit of philosophy and theory there. Again, you can just memorize this. 0 divided by any number is always 0. Any number divided by 0 is undefined. You can memorize that, but if you get to a test and you blank out a little bit, here's how you can kind of rebuild it for yourself. Here's the why behind the rule. All right, let's do some examples dividing with positives and negative numbers. Okay, let's take a moment here, and number 70, we've got a negative 1/2 divided by negative 7/9. I've got a negative divided by a negative. Those are the same signs, which means my answer is going to be positive. Now I don't even have to worry about the signs. I can just focus on the division. And in this section, we're going to set it up as, and it's fractions too, so it's perfect because that's the way we've been taught fractions. 1/2 divided by 7/9 is going to be 1/2 multiplied by the inverse, 1 times 9/7. Okay, so you multiply by the inverse when you have to divide. Okay, so dividing is equal to multiplying by the inverse. And we can peek ahead, see if there's anything that will pre-cancel, and there's not. We've got 1 and 9 on the top, 2 and 7 on the bottom, no factors in common anywhere. And these were both negative. I already know ahead of time my answer is going to be positive, but I can just double check myself. And I end up with positive 9 over 14 is my final version. And here we go with number 76. 8 divided by negative 2/9. That is a positive 8 divided by a negative 2/9. So it's a positive divided by a negative. Those are different signs, which means my answer, I can expect it to be negative. So I can start by rewriting here. It's 8 over 1 times the reciprocal negative 9 halves. Again, dividing is the same as multiplying by the inverse. You were taught this when you were taught fractions, but it really works for all numbers, okay? And that's why we're reintroducing it here, because we want to be ready for the algebra, and it's a great skill for doing algebra. From here, we look to see if there's any pre-canceling, and there is. 8 is the same as 2 times 4, and so those 2's are going to cancel. So what that could look like is we've got 4 times 2 over 1. I'm going to move the paper up a little bit, times negative 9 over 2. The 2's cancel top and bottom. We've got all multiplication on the top, all multiplication on the bottom, so we can cancel these factors. It's like dividing everything by a version of 1. You're dividing by the 2 over 2, which is equal to 1. And that doesn't change anything, just the look of it, not the value. So now we multiply across 4 times negative 9, the whole thing over 1. And so you end up with a negative 36 over 1, or just negative 36. Again, I knew my answer was going to be negative because I pre-looked at it before I even did the math part of it. I looked at the signs and knew I was dividing, knew the signs were different, knew the answer was going to be negative. I could also just follow it all the way through, and here when I do a positive 4 times a negative 9, I've got different signs. I'm multiplying, my answer is negative. Okay, time for you to try number 72, and I'll get that back centered on the screen for you. Hit pause, and then we'll reveal the answer. Alright, when you do this division, you should end up with a negative 1/10, and we'll cover those tries step by step in class together. And on to page 3.